All right, let's go back to this. Okay, so the last time we were talking about rifting, um, but by the way, this is the when you talk about like how slow the continents move very slowly due to rifting and subduction. Uh, you know, this would be considered speedy, right? Very so 10 centimeters per year, right? Would be moving rather fast. The Mid Atlantic Rift, it's less than it's less than 3 centimeters per year. So I mean, it's actually closer to 2 centimeters per year. It's 2 point something. I forget exactly what it is. But that's the average. That's the average speed. So some years it'll be a little more. Some years it'll be a little less. Um, but that's the estimate of the average speed. All right. So and so that was rifting. It's when the material separates, and that just doesn't just happen in the middle of the Atlantic. There are other regions around the world, but it does usually happen in the oceans. All right. Now this thing called subduction is usually where the oceans meet the land, and in fact when subduction is taking place, you can often think of this as mountain building, right? And so that's when one. So I'm already going to talk about plates because we know that that's exactly what's taking place. This is, I didn't mention it with rifting, but the continents are these plates that basically float on the mantle and sometimes they collide, sometimes they move apart, like it's going on with rifting. So this subduction is when the plates are colliding, and one plate is less dense than the other. So the ocean plate will sink down below the continent, and what happens is you have mountain building. And think about like along the coasts. Well, not right on the coasts, okay, but like for example, the Rocky Mountains, right? The Rocky Mountains are on the western part of the United States, and they have been they're actually still growing in height, and that is where the North American plate is being is well, sorry, the Pacific plate or parts of the Pacific plate are crashing into and and so that's causing this mountain building, and it continues to this day. The Appalachian Mountains, for example, are much older. They're not currently growing, but that was another subduction zone that took place a long time ago. You know, hundreds of millions of years ago, as a matter of fact, is when the Appalachians began to grow. All right, so this is what we find, and this is a good description. Is we have a changing face of the Earth, and human, we didn't know this for a very long time. This really is less the our knowledge of the fact that plate tectonics, which is what it's called, when these plates move around across the surface of the Earth, uh, that wasn't known. In fact, like these things called these earthquakes and volcanic activity, really that goes hand in hand with the plate tectonics, right? Where areas where there's lots and lots of volcanic activity and earthquakes, like for example, right along, the Rocky Mountains and well, anywhere that you find mountains, pretty much. and of course the Andes Mountains. And if you can go along Alaska, which you can't really see right here. There's lots and lots of volcanic and earthquake activity, and then even right along the eastern coast of Asia here, right? Like so along Russia and China, and of course think about Japan, right? Japan has earthquakes and volcanic activity all the time. Indonesia, and even parts of Australia. Australia and then these island nations as well in the Western Pacific. All right, and of course, so here in fact, there's a really good example of subduction. So let's go back to this idea of subduction. When one plate crashes into another, probably the best example of that is right here, right? So the India is actually on its own little plate, the Indian subcontinent, and so that is actually crashing into this continent here is called Eurasia, Europe and Asia, and so as this plate right here crashes, it's actually creating a subduction zone, and that's actually what the Himalayas are. The Himalayas are the highest mountains currently, the highest mountains in the world, and so and in fact they're still growing because this subduction is ongoing, right? It's an ongoing thing. I mean, it's very slow, right? It's an extremely slow thing. Let's see what else. Yeah. All right. So let's just move on. So the shifting of large blocks of the Earth's surface is called plate tectonics, as I have already mentioned. Early researchers noted that. So if you look at the eastern coast of South America and the western coast of Africa, they look like they fit together like a jigsaw puzzle. I mean, people noticed that, about 150 years ago, and it was a little more than 100 years ago that some geologists, or one geologist in particular, said, "Hey, maybe there was a time in the past where the eastern coast of South America and the western coast of Africa were joined, and there wasn't this giant ocean in between them." And this guy, so this was right around 1912. The guy that proposed this said that, hey, there was a supercontinent, and he even named it. It was called Pangaea, or he named it Pangaea. So there was this one single continent, and that broke up. Now he didn't know exactly how long ago Pangaea had broken up, but now we know that it was about 250 million years ago. So you can actually even now go into the fossil record of dinosaurs and even the creatures that lived right before the dinosaurs, mostly reptiles, and you can see that it's the same creatures on the eastern coast of South America and on the western coast of Africa. I'm sorry. Yeah. The western coast. Sorry, the western coast of Africa. It turns out they were if you go back 250 million years ago, you get the exact same creatures. And then as time went on, as the continents shifted, as plate tectonics, took place, and then you had this rifting where the continents moved apart here. The animals began to diverge. They began, to evolve in their own directions, and so you can actually see that in the fossil records that the creatures that lived along the western coast of Africa, and the creatures that lived along the eastern coast of South America completely diverge within, just a few 100,000 years of each other. And then certainly, as millions of years go by, the creatures are completely different, right? All right, so that's that is this, that's fossil evidence of that. Of course, we have more than fossil evidence. There's geological evidence that we have. I mean, we can actually measure this now, right? We can measure how much the rifting is taking place. One of the things that this just to let you know, this mid-Atlantic ridge does is it goes right through Iceland, right through almost the middle of Iceland, and so Iceland is actually undergoing rifting, and there are geologists who measure this all the time, right? So, all right, so the people used to laugh that they thought that this was a ridiculous idea. That of course the continents were always the way they were, and of course they didn't even know how old the Earth was. I mean, they thought the Earth was maybe a few thousand, several, maybe tens of thousands of years old. Nobody really knew how old the Earth was. And then when geologists started to look at the rocks, it very, once they applied the scientific method, they found that the Earth had to be at least, millions upon millions of years old. And then, as time went on, our methods got a little more precise, and then we found that the Earth was not, not hundreds of millions of years old, but really billions of years old. In fact, 4.5 billion years old. All right, so, and of course, the Earth has undergone lots of changes. So Pangaea is this supercontinent that existed, not lived. It existed about 2.5 million years ago. Actually, there were living creatures on Pangaea. The precursors to the dinosaurs lived on Pangaea. All right. Anyhow, that's so. This is some of the pictures that we have of we kind of figure out what was going on with the Earth. For a long time there was just this one continent. This is not exactly a course in geology, but there were different parts of Pangaea that began to break apart over different times, and so roughly about 2.5 million years ago is when Pangaea really begins to break apart, and of course today is the continents are where they are, and that really begins 2.5 million years ago. Okay, so all right, so that's the movement of the crust of the Earth. Remember, that's caused by convection, convective currents, heat current that moves deep inside of the Earth. All right, so another phenomenon that happens that happens inside of the Earth that has another effect, although we don't actually see it for the most part, is the Earth has a magnetic field. It's certainly not the strongest magnetic field in the solar system, but it does have a magnetic field. For example, our moon has no magnetic field, and Mars, the planet Mars, has no magnetic field. Yeah, here, let's look into this for a little bit. All right, so for the Earth to have a magnetic field, I mean, we actually understand